Now we will define the continuity. Suppose we have a function fx and we have to check the continuity of the function at point x equal to a. So definition is that a function is continuous at x equal to a if left hand limit at x equal to a is equal to right hand limit at x equal to a is equal to the value of function at point x equal to a. That means we can write that limit h tends to 0. For left hand limit we will write f a minus. It is equal to limit h tends to 0 and right hand limit is a plus, and that should be equal to fa. Also we can write it as limit h tends to 0 f a minus h equal to limit h tends to 0 f a plus h, and it is equal to fa. Earlier we have already stated that if left hand limit is equal to right hand limit, then we say limit exists, and if limiting value is equal to the function value, then we say function is continuous at that point. Suppose this is x-axis and y-axis and function is defined here. There is a point x equal to a where we have to check whether function is continuous or not. For that we will find the value of the function at a, this is fa, and left hand limit is the value of function while we approaching to the point a from left hand side, that means it is a minus. So this value gives fa minus. And from right hand side, if you approach the point x equal to a, there is a point, this is a plus, and value of the function at this point is fa plus, and this fa minus, fa plus and fa are equal, then we say function is continuous at point x equal to a. We will use this definition to check for our modulus function, which was defined as mod x and given as x if x is greater than or equal to 0 and minus x if x is less than 0. For this function we have to check whether function is continuous at x equal to 0. If we draw the diagram, this is x, this is y, then modulus function is drawn here. This is the modulus function y equal to mod x, and by observation we can see that if we draw the graph without lifting a pen in the domain, then this function is continuous function. That means it will be continuous at x equal to 0. By definition we also can check it. For that, first we find left hand limit, it is equal to limit h tends to 0, then f a minus h. This f a minus h, and a value is here 0 because we have to find the limit at x equal to 0, so we write it as limit h tends to 0, 0 minus h, and this 0 minus h is a negative value, so by definition we have to move for f less than 0. For that value is minus x, and we substitute here, it is limit h tends to 0, and then it is minus, and it is 0 minus h, so it will come limit h tends to 0 h, and substituting the value of h we will have the left hand limit limiting value 0. Similarly we can find right hand limit. This is limit h tends to 0, definition is a plus h, a is 0, point where we have to find the limit, so it is limit h tends to 0, this is f 0 plus h, and it is equal to, because 0 plus h is greater than 0, so we will go to the definition where x is greater than or equal to 0 and having the value of the modulus function x. So we write here, it will be limit h tends to 0, and it is 0 plus h, that is equal to limit h tends to 0 of h, and putting the value of h equal to 0, we will have the value 0. So left hand limit equal to 0, right hand limit equal to 0, and function value at x equal to 0 is, by definition we go to the branch x greater than or equal to 0 where value is x, and because x is 0, so f0 is also 0. So we can see here left hand limit equal to right hand limit equal to the function value at that point. So we say function is continuous at x equal to 0.